Alright, today we pick up in section 6 of chapter 5, so chapter 5-6, and we're going to focus on our half-angle identities. The last section we focused on double angle identities. We've done, we've done our sum and difference identities, cofunction identities, all the fundamentals. We've done product to sum and sum to product. We've done our double angle, and now we're picking up our half angle identities. Now, the half angle identities rely on you comparing the argument of one side to the argument of another. It doesn't necessarily have to have a fraction in it. For example, if I have 4x as my argument, what's half of 4x? Well, half of 4x is 2x. So half of 4x is 2x. So these two have a relationship that 2x is half of 4x. If my argument is 2x, well, what's half of that? That would just be x. So a half angle identity would express these two arguments as x being half of 2x. Well, what if my argument is just x? Well, half of x is x half. So those two, this is half of x. So these have a relationship as being a half angle, half of x. So you don't have to have it set up like this. You could come into contact with it like this, also like this, but more frequently it's going to show up as that relationship from one side to the other, that the arguments, you have an argument that is half of the other argument. So we're going to start out by deriving a half angle identity. We're going to derive one of our half angled identities, and to derive that we're going to start with the double angle. We're going to start with one of our double angle identities. Let's start with cosine of 2x. Well, when I go look at my double angle identities, I see that I have three different options for double angle cosine. We're going to start with 1 minus 2 sine squared x. That's the one we're going to pick to use to derive our half angle identity. So the first thing that we're going to do is we are going to rewrite the left side, we're going to rearrange and rewrite so that we have, instead of the terms in this order, we're going to move this 2 sine squared x over to the left, and we're going to move our cosine 2x over to the right. So I'm going to add 2 sine squared x in order to move it over to the left. Sorry, I've lost the color I was looking for. So I'm going to add 2 sine square x to both sides. And I'm going to subtract that cosine 2x to rearrange all my terms. So I'm going to rearrange. So now I have 2 sine square x is equal to 1 minus cosine of 2x. Well, now I have it set up where x is the argument on the left. It is half of the argument on the right, the 2x. So now we're just going to solve for sine of x. Well, I need to divide both sides by 2, and that gives me sine square x equals 1 minus cosine 2x all over 2. And then to finish solving for sine x, I'm going to need to take the square root of both sides. Now, since I'm solving for an unknown, when I take the square root, I have to consider plus or minus. So that gives me my half angle identity. Sine x is equal to plus or minus square root of, and everything is underneath that radical, 1 minus cosine 2x over 2. I have an argument here that is half the argument over here. Another way to write that would be to say, okay, well, that's going to be the same thing as expressing it as sine as half x equal to plus or minus square root of 1 minus cosine x over 2. So either way These are both ways to express a half angle identity because the argument on the left is half of the argument on the right. Okay, so let's fill in our definition box down here. In these half angle identities, that plus minus symbol indicates that the sign is chosen based on the function under consideration and the quadrant of the half angle. Now, this is important. This is something a little bit unique when we're using our half angle identities. I want you to think about finding the half angle. Well, for example, 150 degrees is over here in quadrant 2. In quadrant 2, my cosine is negative, my sine is positive. But half of 150, if I'm interested in the half angle, half of 150 is 75. Well, 75 is going to be right about here. It's in quadrant 1. And in quadrant 1, both cosine and sine are positive. Let's think about another one. Let's do 240. If my angle is 240, I'm in quadrant 3, quadrant 3, and in quadrant 3, sine and cosine are negative. But half of 240 is 120. 120 is up here in quadrant 2, and in quadrant 2, cosine is still negative, but sine is positive. So when you're interested in half angles, you have to think about which quadrant that half angle will fall in and choose the sign based on that quadrant. Okay, so we derived sine of the half angle. That's the one that we just did together. We said, okay, that's going to be plus or minus, depending on the quadrant, the square root of 1 minus cosine, and notice that my argument here is a, cosine a over 2. That's the one we derived. We're not going to derive the others. Cosine of the half angle looks just like sine of the half angle with an algebraic sign change. So my numerator in there and inside my rational expression is going to be plus. So 1 plus cosine a over 2. Notice that we have 3 different options for tangent of the half angle. And in reality, you can see these written in a little bit alternate forms on some places. These are just the ones that we're going to focus on and work with. My first version of the tangent half angle, I'm going to set up by saying plus minus all under the radical 1 minus cosine a over 1 plus cosine a, which makes sense because tangent is sine over cosine, right? And we've got those numerators, the denominator would cancel out. Another way of thinking of tangent of the half angle is to do sine a over 1 plus cosine a, or 1 minus cosine a over sine a. And we're not going to take the time to derive those. If you're interested, you can look them up in our book, or you can find them online. All right, so here we go, applying these half angle identities. We want to find the exact value sine of 22.5 degrees using the half angle identity for sine. Now, whenever I see exact value, that means I'm not going to be pulling out my calculator because a calculator is going to give me an approximate value. But half angle identity, that's my hint. Well, 22.5 is definitely not a special angle, but it's half of 45. So sine of 22.5 degrees is going to be the same thing as the sine of half 45 degrees, right? Because 22.5 is half of 45. And this sets me up for a half angle identity where A is 45 degrees. So I can use that half angle identity. Now I don't need to do plus minus because I know that this angle 22.5 degrees is in quadrant 1. So sine is going to be positive there in quadrant 1. Using my half angle identity here, I have 1 minus cosine A, where A is 45 degrees. So 1 minus cosine of 45 degrees all over 2. Well, 45 is a special angle. Cosine of 45 is square root 2 over 2. That's all underneath this radical. Now, the easiest way to approach this, there are various ways to approach this, but the easiest way to approach this is to multiply underneath that radical by a well-chosen 1 that's going to clear out this little internal fraction. So I'm going to multiply underneath my radical by 2 over 2. When I distribute this, I get 2 times 1 is 2. And this was the purpose for doing this multiplication. This is going to cancel out that 2 here and leave me with just 2 minus square root 2 in my numerator. 2 times 2 is 4. That's my denominator. And all of this is underneath that radical, that square root. Now remember how we work with radicals. I can split this fraction into 2 separate square roots. So my numerator is 2 minus square root 2, and my denominator is square root 4. Well, square root 4 will simplify. That's just 2. And in my numerator, I leave that stacked radical. I don't need to do anything else with that. I am done. So my numerator is the square root of 2 minus square root 2, and my denominator is 2. Now I'm pointing this out more than once because you've got to make sure that when you input your result into MyMathLab that you get everything in its proper place. The denominator is not underneath the radical. Okay, so let's do another example. We're using our half angle identity again. There's my hint for that tells me what I'm looking for. I want cosine of 15 degrees. 15 degrees is in quadrant 1. It is not a special angle, but it is half of a special angle. So if I want cosine of 15 degrees, I can say, okay, you know what? Well, 15 degrees is half of 30 degrees. 15 is the same thing as 30 divided by 2. And now I have a cosine half angle identity. Plus or minus, well, 15 degrees is in quadrant 1, 30 is as well, but I'm interested in this one. 15 degrees is in quadrant 1, cosine is positive in quadrant 1. So I'm going to have 1 plus cosine 30 degrees over 2, because for my half angle identity, a over 2, I've got 30 over 2 here, so a is 30. For this one, a was 45. For this one, a is 30. Well, hopefully by this point you know that the cosine of 30 degrees is square root 3 over 2, but if not, you've got your unit circle to glance at. And we get this fun, crazy rational expression stacked underneath my radical. So I need to clean that up. I'm going to clean it up by multiplying by that well-chosen 1, distributing so that I get square root of 2 plus square root 3 over 4, all underneath the radical. I can't simplify my numerator, but the square root of 4 is 2. So when I rewrite this as a 2 here, I no longer have that denominator underneath my radical sign. That's just a denominator of 2. Okay. So that's how we apply these half angle identities. Let's move on and do a different type of example with them. We're going to find the exact value of tangent 75 degrees using this identity. Now, it gave me a specific half angle tangent identity because there are 3 of them to choose from, and it wanted me to practice with this one. So we're going to do that. We're going to do what it says, tangent of 75 degrees. 75 is not a special angle. It is in quadrant 1. So in quadrant 1, tangent is positive. I'm going to use this identity. Well, if this is the half angle, what is it half of? 75 is half of 150. So tangent 75 degrees is the same thing as the tangent of 150 divided by 2, which means that this 150 is my A. So that's going to be found by doing sine at 150 degrees over 1 plus cosine of 150 degrees. Okay, so I refer to my unit circle. 150 is 30 degrees off of my x-axis. That reference angle is my 30-degree angle. Cosine is square root 3 over 2, sine is 1/2, but since I'm in quadrant 2 for 150 degrees, I use a negative square root 3 over 2. So sine is 1/2, that's my numerator. Cosine is a negative square root 3 over 2, that's my denominator. I've got this ugly stacked rational expression again, so I'm going to use my multiplying by a well-chosen 1 to clean out those internal denominators, which gives me 1 over 2 minus square root 3. 2 times 1/2 is 1, 2 times 1 is 2, 2 times this square root 3 over 2, those 2's are going to cancel here. So I have 1 over 2 minus square root 3. Now, we have to rationalize our denominator, and since I have 2 terms in my denominator, I rationalize by multiplying by the conjugate of that denominator over itself. So my well-chosen 1 is the conjugate of 2 minus square root 3. 2 plus square root 3, 2 plus square root 3. When I multiply by that well-chosen 1, I've moved my radical to my numerator, so my numerator is just 2 plus square root 3. When I FOIL this, FOIL conjugates, that radical is going to take care of itself, right? 2 times 2 is 4. I have a negative or a positive 2 square root 3 and a negative 2 square root 3. Those add to 0. And then a negative square root 3 times a positive square root 3 is minus square root 3 squared, which is just 3. So in essence, I have 4 minus 3 as my denominator, and 4 minus 3 is just 1. So my result is 2 plus square root 3. Okay, here we go again. I want you to pause the video, practice this on your own, see what you can do. Notice that we've been instructed to use that same identity again for half angle tangent. And then come back and see how you did. Once again, we have to rationalize using the conjugate. My numerator isn't quite as pretty here. Square root 2 times 2 minus square root 2 times square root 2 is just 2. My denominator is going to clean up nicely. 2 times 2 is 4. Outside and inside products add to 0, and this ends up being minus 2. So I've got 2 square roots of 2 minus 2 over 2, and I need to simplify as much as possible. Those 2's are going to, however you want to think of it, factoring a 2 out of the numerator and then they cancel, or you can split it apart into 2 terms, and either way it's going to cancel to be square root 2 minus 1. Make sure that you're careful about where that radical shows up, how you write your result. Alright, example 3. Alright, so we are given some information about S. I'm going to hit autofocus. It's going to blur it out. It'll come right back. We're given some information about our angle S, and we want to find values of the half angle, so half of S. Now, since S is not given to us as a certain number of degrees, we can't just step out and say what quadrant S is in without some more information. So we're told that S is between pi and 3 pi halves. Well, pi to 3 pi halves is quadrant 3. To find the quadrant of the half angle, we divide everything by 2. So I take this information and I say, okay, well, if I find the quadrant of the half angle, I'm dividing everything by 2. My half angle is going to be S half is going to be between pi half and 3 pi 2 divided by 2 is times a half, so that would be 3 pi fourths. Between pi half and 3 pi fourths, well, pi half is 90 degrees and 3 pi fourths is in quadrant 2, so my half angle is going to be in quadrant 2. In quadrant 2, sine is positive, cosine is negative, and tangent is negative. So that clears up algebraically what those algebraic signs should be. So we have 3 pieces of information to find. We are given this starting place, cosine of s. So the first thing I need is the sine of s half. When I go back and I look at my half angle identities, the sine of s half, I've got this right here. I know cosine of s, so I'm in good shape. I have something to plug in. And I know that in quadrant 2, sine is positive, so that takes care of that. So I start with 1 minus cosine s over 2, because that's my half angle identity, the positive version because of the quadrant I'm in. And I'm given that cosine of s is a negative 3/7. So 1 minus a negative becomes 1 plus 3/7 as my numerator. I need to clear up this little internal fraction by multiplying by that well-chosen 1, 7 over 7 in this case, which leads me to 7 plus 3, because I distribute that 7 in my numerator, over 14. And 7 plus 3 is 10, so I've got square root 10 over 14. Well, 10 over 14 is going to simplify to 5/7, right? I don't need to leave a radical in my denominator, so I need to split these apart so that I can rationalize my denominator. So I'm going to multiply by square root 7 over square root 7, which gets me to 5 times 7, that's square root 35 for my numerator. Square root 7 times square root 7 is 7 for my denominator. So that is sine of the half angle. Alright, let's go through and let's do cosine of the half angle. Cosine of s half. Well, we only have one cosine half angle identity available to us. It is 1 plus cosine s over 2. I know that I've already determined that based on the quadrant I'm in, this cosine value needs to be negative, so that's my algebraic sign that gets stuck out front here. So now I have a negative square root of 1 minus 3 over 7 over 2. I've got to do that same little step where I clear out that internal fraction by using that well-chosen 1. So now I've got a negative 7 minus 3 over 14, which gives me a negative 4 over 14, which is a negative 2/7. And now I'm to the point where I need to rationalize again, right? So I'm going to go ahead and say a negative square root 2 over square root 7. Rationalize that denominator. Gives me 2 times 7, I've got a negative square root 14 over square root 7, and square root 7 is just 7. Now, this does not simplify, just like this one did not simplify. I can't simplify and stay exact the square root of 14. That is not divisible by 7 because that 7 is not underneath the radical. Alright, next, last, tangent of the half angle. Now, I've got some options here. We're going to go ahead and practice using my tangent half angle identity. And remember our rule of thumb that we use our givens, not found values. Well, we were only given cosine of A. We found a value for sine of that half angle. Or no, actually, let me walk that way back. We don't know the sine of A. We found the sine of the half angle, but we don't know the sine of the angle. All we know is the sine of the angle, or the cosine of the angle. So this is the half angle identity that we definitely need to use because that's the only information we have. We don't know this. I know that it's going to be negative. So when I set this up, I have a negative out front, 1 minus cosine s over 1 plus cosine s. My cosine s is still this negative 3/7. So I've got a negative, and then underneath my radical, 1 minus a negative becomes 1 plus 3/7, 1 minus 3/7. Do my multiply by the well-chosen one trick. Not a trick. Legal move, right? 7 plus 3 is my numerator. 7 minus 3 is my denominator. So I've got a negative 10 over 4, which is a negative 5/2 underneath my radical, or instead of reducing by 2, 4 is a perfect square. So if I split that apart, if I split that radical apart into a numerator and denominator, I can rationalize, or I don't have to rationalize, I can just simplify my denominator, and I get negative square root 10 over 2. Now the other way I was saying that you could deal with this would be to work here, and because I also know that tangent, I have sine of the half angle and cosine of the half angle, and I know that my quotient identity for tangent is that it's sine over cosine. So I could set these up one over the other. The 7s would cancel, and then I would have to rationalize that square root 14. I would get to the same place. Whichever way you see that to move forward is going to be okay, unless it specifically tells you to use your half angle identities. Okay, let's do a few more examples, and then we will be done with chapter 5 and ready to move into chapter 6. All right, I'm going to kind of divvy up our space here. Simplify each expression using our half angle identities. Now, I am given, for each of these, I am given the right side of a half angle identity. So here's my identity list. I have 1 minus cosine 8x over 2. I've got this plus or minus out here. Well, my plus or minus identities are these three. I've got 1 minus cosine over 2, so that's got to be sine of the half angle. And remember that discussion about our relationship between the two arguments? So underneath my radical, that argument is a. So this is the same thing as saying plus or minus square root of 1 minus cosine a over 2, where a is 8x. Well, that's my right side. The left side, sine of a over 2, where a is 8x, means I have the sine of 8x over 2, which simplifies to be 4x. And that's all we've been asked to do there. Okay, let's look at another one. This time I have 1 minus cosine over 1 plus cosine, and then the argument that I have here is 9 beta. So that's my argument I'm going to be working with. Now 1 minus cosine over 1 plus cosine, that's my tangent of the half angle. So I've got tangent of a over 2, where a is 9 beta, so that's tangent of 9 beta over 2. I can't simplify that, so that's it. I'm done. Don't try to make these harder than they are. Pause the video, take a look at C and D, see if you can work those out on your own. It's 1 plus cosine in the numerator, so I know that this is my cosine half angle. Here I've got a mix. I've got cosine and sine. I don't have a radical. Well, the only half angle identities that matches the right side of these tangent half angle identities. Right here, it matches this one, where this argument that I'm given is a. So my argument is 5 alpha. So I've got tangent of half a, where a is 5 alpha, and I don't have any other information, so that's all I got. I'm done there. All right, excellent. Let's practice verifying a couple of identities. Okay, so I got choices here. Now, we're going to do this one first. I see I've got tangent of a half angle squared, which is not the same thing as the tangent of the half angle exactly, right? Tangent of the half angle, I've got 3 options here. Since I have 3 options, I don't know which one to start with. So I'm not going to start with this left side. I'm definitely going to start with the right side, which looks more complex. Keeping all of that in mind about the left side, that this is a half angle tangent, but it's been squared. Okay, so I've got secants and cosines. Secant is the reciprocal of cosine, yes? So let's put everything in terms of cosine and see what happens next. So that would be 1 over cosine x plus cosine x minus 2, and this would be 1 over cosine x minus cosine x. And I've got that situation where I've got those little internal denominators, internal fractions, and we like to clean those up. We clean those up by multiplying by that well-chosen 1. So I'm going to multiply my numerator and denominator by cosine. Well, when I distribute in my numerator, cosine x times 1 over cosine x, that's just 1. Let me get a different color here. That's going to be 1. And then cosine x times cosine x is cosine square x. And then this is just minus 2 cosine x. That doesn't clean anything. But notice that that little denominator in my numerator, that little internal fraction here is gone. That's this distributing this cosine x into my denominator is going to make that same thing happen. Okay. So, let's think factoring. That's the next step. Let's think factoring. My numerator is a perfect square trinomial. My denominator is difference of squares. So let me rearrange my numerator a little bit. I'm going to make that 1 minus 2 cosine x plus cosine square x. And I left it in this order because of my denominator being 1 minus cosine square x. And now let's factor both of those, numerator and denominator. So my denominator is difference of squares, 1 minus cosine x, 1 plus cosine x. My numerator is going to be, since it's a perfect square trinomial, it's going to give me 2 identical factors. It's going to give me 1 minus cosine x times 1 minus cosine x. So you may need to review some factoring from college algebra. Khan Academy is a great place to Google factoring quadratics. Okay. So anytime I have anything over itself, that's 1. So right there, that's a 1. And that leaves me with 1 minus cosine x over 1 plus cosine x. 1 minus cosine x over 1 plus cosine x. Well, did this get me anywhere? 1 minus cosine x over 1 plus cosine x. Well, I see that I've got a tangent half angle here, plus or minus the square root of that. I don't have a radical here. So maybe let's go back up to the top and let's deal with this. Tangent squared of the half angle is the same thing as tangent of the half angle squared. And we want to use that identity that looks like this, right? So that half angle tangent identity would be plus minus square root of 1 minus cosine x over 1 plus cosine x. And if I've got that squared, if I've got this identity and I square it, the square and the square root cancel out. Anything times itself is positive. So that leaves me with 1 minus cosine x, 1 plus cosine x, and those match. So notice I did not work back and forth. I worked down the right side to simplify, and then I went back to the left. I said, oh, I know what to do with this now. And I worked to get to a common point on both sides. All right, one more identity that we're going to focus on, and then we're done with chapter 5. Okay. Well, 1 plus sine x is really simple. I don't have anywhere, I don't know where to go with that. So we're going to do something with this right side and see if we can end up at 1 plus sine x there. So I've got sine of the half angle plus cosine of the half angle quantity squared. I've got some choices, but I'm going to go ahead and square this binomial. When I square my binomial, I square the first term. So that's sine squared of x over 2. I think about multiplying the two terms together times 2 because the outside and inside products are the same. If you need to FOIL this, if you need to write it down and FOIL it and look at each step separately, that's fine. Do that. And then I square this last term, which is going to be cosine square of the half angle, x half. Now, my Pythagorean identity says sine square plus cosine square is 1, and that holds true no matter what the argument is. Sine square plus cosine square is 1. That's my Pythagorean, that's basic Pythagorean identity, right? So that gives me 1, and then I've still got plus 2 sine x half cosine x half. Now this looks very familiar. It reminds me of one of my double angle identities. So this is why you need to be super familiar with your identity sheet. 2 sine A cosine A is equal to sine of 2A. Notice that relationship between those arguments. So if what I have, this is a double angle identity. For this identity, A is half of 2A, so x half is half of x. So that becomes 1 plus, that is my sine double angle, so that is going to be sine, well, twice x half is just x. Ah, and we're done. That was what I was after. We verified that identity. That is an excellent example of how important it is to be familiar with your identities. Now, is that the only way to do it? No, absolutely not. It is not the only way to do that. In fact, let me just show you. I'm not going to walk through this, but I'm going to show you because you guys can pause this and walk through it. If I, instead of multiplying this out, if I chose to replace these with the double angle identities, I would have gotten there as well. So this is an alternate way to verify that identity by using my half angle identity substituted in and then FOILing and simplifying. I would have gotten there.